functions. Remember that inverse functions in general are the functions that undo other functions. So like our square root and our x squared, inverses of one another. So we also have inverses of our trig functions. Now, there is something particular that we first need to kind of set up, which is a one-to-one function. So a one-to-one function is a function whose inverse is also a function. And we can check this by using the horizontal line test. So hopefully y'all are used to using our vertical line test to check if something is a function. And in the same way, I could use our horizontal line test to check if something is one-to-one. So if I have the graph, let's say it's just a linear graph, would that function be one-to-one? In other words, if I draw a bunch of horizontal lines, is it going to pass through more than one point in those horizontal lines? It passes through more than one point, or it passes the horizontal line test? Yes, it passes the horizontal line test because it does not pass through more than one point horizontally. However, if I had something, say, that was like a polynomial graph, does that pass my horizontal line test? No. So that one would not be considered one-to-one. We all went there? Now, the reason that we like this is because we like it when the inverse is also a function, okay? Now, sometimes we can slightly get around this. So, if I was looking at the function of x squared, so y equals x squared, does that pass my horizontal line test? No. However, do we know what our inverse for x squared is? Yes. What undoes an x squared? A square root. So what does the graph of a square root look like? Kind of, yeah. So it starts at our origin and then just goes sideways. Is that a function? Does that pass my vertical line test? Yeah, which doesn't make much sense. And the reason is because technically, whenever we find the inverse of this, okay, whenever I take the square root of both sides, we should actually add in a plus or a minus there. So our actual inverse graph would look like that, which is not a function. Which is why they say, okay, what could we do to where I only keep the top part of that graph? Well, I would restrict my original graph to only look at the positive part of that. That way, then, if I only look at this piece, well, now this is a function. Does that make sense? So sometimes there's like a loophole and kind of get around it. And again, the reason is because we like our things to be functions. It makes everything else work out much nicer if everything is a function. So, also remember that our inverses, like we said, undo each other, which we can also write as f of g of x, which is what type of function or operation? Do we recall? What is it called when I plug one function into another function? Composite. So when I composite my two functions together, I should just end up with x, because they undo each other. same thing. So we have y equals sine of theta. We want to find the inverse of that. However, recall that our graph starts at 0. Look something like that. Agreed? So does that pass my horizontal line test? No. Because it repeats itself over and over and over and over again. Which causes problem because that means that our inverse will not be a function. But we want it to be a function. So we're going to do something similar to what we did with our x squared graph. We're going to restrict this so that I only use a portion of the graph. Okay? So what we're going to do is I still want to hit all of my y values. So I still want to go from -1 to 1. But notice that if I go from like 0 to, this would be 3 pi over 2. It's also not going to pass my horizontal line test. So what we're going to do instead is go backwards. And we're just going to look at the part that is from negative pi over 2 to positive pi over 2. What is the range for that? Or what y values does our graph hit? Yep. So the way that we write our inverse function is we sometimes either use a little negative symbol, or you'll also see it written as arc sine of x. So those two things mean the same thing. And remember that to find inverse functions, we just end up switching our x's and y's. So our domains and ranges will also be flipped. So now my domain is -1 to 1, and the range is negative pi over 2 to pi over 2. Questions on that so far? And like I said, basically this allows us to go backwards. So for sine, we plug in an angle and get out a number. For inverse sine, we're going to plug in a number and get out an angle. So we're like working our way backwards. We're trying to think what angle gives us this value.
Wait, how do you get pi over 2? Or is that just like,
Here to here?
yeah, did we just like decide that was pi over 2, or was that like one of the points on like the sine graph?
So this is at 2 pi, because that's one full period. This is at pi. This is at 3 pi over 2. This is at pi over 2. So I'm going by pi's over 2, so this would be at negative pi over 2.
Okay, is that always how like how it goes?
For just sine of x, yes.
Okay.
If you add in like transformations and stuff, not always, but yes, that is what our sine of x graph looks like. So, speaking of going backwards, remember we said that our unit circle wasn't going away, so we still need to remember our things from the unit circle. So, where does sine equal -1/2 on our unit circle? Where does sine equal +1/2? still have a pi over 6 in it, right? So that would be 7 pi over 6. Or 11 pi over 6. Yes? Again, we're going backwards. We're trying to figure out what angle gives me negative pi over 2, or sorry, negative 1 over 2 for sine. The problem is, are 7 pi over 6 or 11 pi over 6 in the range that I put here? No. Okay, but let's think. Again, it has to have a reference angle of pi over 6, right? That's how we got those two. And we know that it can't be like pi over 6 because that would be positive. So we know we have to go backwards. So going backwards, what's going to have a reference angle of pi over 6? Don't make it more complicated than it has to be. So the options that we have going backwards are going to be negative pi over 3, negative pi over 4, and negative pi over 6. Which one of those has a reference angle of pi over 6? Negative pi over 6. So my answer is negative pi over 6. So the negative is because we're going backwards, and I still have to have a reference angle of pi over 6. Now when it's positive, it's a little bit easier. Where does sine equal square root of 3 over 2? Is there anywhere else? Two pi over 3? But pi over 3 is the only one of those that is before pi over 2. So that would be right. Yes? So again, some of us might need to review our unit circle a little bit. We're still not remembering those. What? Yeah. Because again, it has to have a reference angle of pi over 6, but it has to be within negative pi over 2 to pi over 2. So I can't use 7 pi over 6 or 11 pi over 6 because that's not within our range that we found. So I said that if I go backwards, that's going to give me a negative value that we need, and I need a reference angle of pi over 6. So that's why we put the negative pi over 6 instead. Alright, now is 2 on our unit circle? Like, do I get a y value of 2 somewhere on our unit circle? No. So, the way that works then is if we have something that's not on our unit circle, that's when we use our calculator. And we use the second button, and then your sine button, and that gives you sine inverse, and then you type in whatever it gives you. And it should, sometimes, give you an angle value there. But what happens? Domain error. Well, because again, let's think. We're saying what angle gives us 2 for sine. Well, do I ever get 2 for sine? Do I ever hit 2? No. So that means that I also can't plug in 2 for arc sine. So we would just say that this is undefined. So if you try and plug in something that's bigger than 2 or smaller than, bigger than 1 or smaller than negative 1, it's going to give you a domain error. Questions on that? Okay. So remember that we talked about how they undo each other. So this also applies with our sines. So I have sine of sine inverse of x just has to equal x, and sine inverse of sine of equal theta, because theta do each other. So what does that mean that this has to equal? Yes. What's the only thing that we have to be careful about? What is our range? Negative 5 over 2 to 5 over 2? Is 5 over 3 within that? It's in our fourth quadrant, right? So again, how do I get a reference angle of pi over 3, but go backwards? Negative 5 over 3. That's it. Let me just say negative 5 over 3 instead. Yay. So that's going to be the hardest part, really, with any of these, is just checking to make sure that your answers are within the correct interval. Alright. So, we can also have inverse cosine and inverse tangent. They work very similarly. The only difference is, remember that our cosine graph starts at 1, and that one looks something like that. So again, does that pass my vertical, or sorry, my horizontal line test? No. So again, we have to restrict the portion that we're going to use. The only difference now is that this second value is going to be at pi. So, for our cosine, we're going to let the domain go from 0 to pi, and our range is still negative 1 to 1, which means that our domain and range of cosine inverse are flipped. Are we all okay with that? So for our tangent, we just end up using this middle portion. Which hopefully we recall is also from negative pi over 2 to pi over 2. What is our range for our tangent function? All real numbers, so negative infinity to positive infinity. Which also means that for our inverse tangent function, we can plug anything into that, so that's kind of nice. backwards with that. So this just says basically the same properties apply to the other one. So arc cosine of square root of 2 over 2. In other words, where does cosine equal square root of 2 over 2? What do we think? So we're still just using our unit circle. So again, thinking about our unit circle or your graph. Sometimes it's easier to like envision the graph. Okay, where does cosine equal -1? Pi. Our answer would be pi. Where does tangent equal 0? Or where does it cross the x-axis? Where does tangent cross the x-axis? 0. So this would be 0. Then where does tangent equal -1? Do we remember where does tangent equal +1? So remember that in order for tangent to equal 1, sine and cosine have to be the same thing. So where are sine and cosine the same thing? Pi over 4, but they would both be positive, so we would get a +1. Yes? So, in order for it to be negative, what? Yes. But remember that we have to go backwards, right? So if we go backwards, what's going to have the same reference angle as pi over 4, but going backwards? Negative pi over 4. So this is negative pi over 4. Yes? Questions about any of this? Or inverses so far? Okay. Right? What is tangent of arctangent of -5? Is it? You just have to make sure. What numbers are we allowed to plug in for arctangent? All real numbers. So is it okay that we have -5 there? Yeah, so we can just get out -5. Now, if it was like arcsine, then we couldn't, because we can't take arcsine of -5. Okay. Now, what about cosine inverse of cosine? Sorry, cosine of cosine inverse of pi. Okay. Well, again, let's go back. What is our domain for cosine inverse? -1 to 1. Is pi within -1 to 1? No. So can I plug pi into cosine inverse? No. So this is undefined. Now, if it was the opposite, if it was cosine inverse of cosine of pi, that would equal. But it's because I'm trying to plug that number into the cosine inverse first that it like doesn't work. Yes? No meaning? Alright, let's do pretty cute. We're mixing things. So I don't have like arcsine of sine or cosine of arccosine. Okay. So So what we're gonna have to use here is go back to what are trig functions? Or what do trig functions relate? Think about like all the way back to last chapter. What was our definition of what is a trig function? Sides of a triangle to an angle. So we're just gonna have to go back to like drawing some triangles. So I don't know what angle this is. I know that it's a lovely triangle, but I know that cosine is 2/3. So cosine is what ratio? Okay, so I know that my adjacent has to be 2. My hypotenuse has to be 3. Okay. I don't know what my opposite is, but basically what I'm going to do then is I've drawn my triangle. Then I'm just going to take tangent of that triangle. So remember that tangent is going to be opposite over adjacent. So I need to figure out what my opposite side is. So what would I use? The Pythagorean theorem. So we would have 3 squared equals x squared plus 4. Agreed? So x equals the square root of 5. So now we know that tangent of our cosine of 2/3 equals, like I said, so tangent, remember, is opposite over adjacent. So it's going to be square root of 5 over 2. So my next one is going to work very similarly. What's the only difference? It is. So when I draw my triangle, what is sine this time? Okay, so my opposite is going to be 3. My hypotenuse is going to be 5. Yes? Can my hypotenuse ever be negative? No, so the negative has to go with 3. So then what type of triangle does that have to be? 3, 4, 5. Which is nice because then now, what is cosine of that triangle? 4 over 5. So just because we're mixing and matching this, we still just go back to like, as long as you can draw a triangle. And remember your trig ratios. So we do have to remember like which one goes with which. So which one's opposite over hypotenuse, which one's adjacent over hypotenuse, which one is opposite over adjacent. And it doesn't matter like which ones you mix and match.